Hi all, in this lecture we'll be discussing about the last and final portion in our module 1 that deals with contours and contouring. So I hope you might have heard of the term contour in our common life, that is when we deal with this portraits and images and all. So in such cases we can see some imaginary curves which are getting highlighted, especially on the face and all. So those imaginary lines are sometimes called as this contours. Similarly, in this surveying and all, we have such a term called contour, which are the imaginary lines that connect points on the earth's surface which are at equal elevation or same elevation. Okay, so in this lecture, we'll be discussing certain features of these contours. These are the main features or main contents that we'll discuss in this lecture, that is characteristics of contours, then methods of tracing the contour or methods of contouring, and why we do this, or what is the purpose of doing this contouring. And before getting into the main content, this given image is that of a topographic map, and in this topographic map you can see a number of curves over which we can see some digits. So those curves are nothing but the contours, and the digits that are written on that represents the elevation of a particular contour, which means what? If you take a single curve, whatever points are coming or falling in that contour will be having same elevation which is written on that contour. For example, you can see here as this 1300. So which means along that contour, all the points will be having an elevation of 1300. That is what is meant by a contour. Okay, so topographic maps are highly useful because it gives not only the plan view, but since it is having contour also, we'll get an idea about the elevation or the level differences between the various regions. So as I mentioned earlier, contours are nothing but imaginary lines on the ground that joins point of equal elevation. Actually, there are no such lines that is visible. It is only imaginary. Okay, we developed it for our own easiness. And the process of tracing contours is known as the contouring. In the we'll be seeing what or how do we do this contouring and all. So in this image you can see, in the first image you can see a hill, and the contour diagram of the hill is shown at the bottom side. So you can see some curves and numbers 30, 40, 20, 10 like that written on over that. So if you look at the top image, you can see that those curves represents the contours that pass through the points having equal elevation. So if you take the curve with number 10, it implies that curve passed through the points on the hill which are at an elevation of 10 meter. Now if you take the upper curve, that is the curve just above that, you can see it is 20. Obviously the curve 20 will be above 10. Similarly, you can represent any contour, that is the contour corresponding to any elevation. So the top portion shows the side view and the bottom portion shows the plan, which is what we are interested in, that shows the contours. Okay, now the same is graphically represented again in the second figure. So there is a hill, and we can plot or we can find the points which are at same elevation, and if we join these points we will get the particular contour. So next term is the contour interval, which is nothing but the constant vertical distance between two consecutive contours. So it can be explained by observing the figures that are given. In the first figure, you can see the contours are 20, 25, 30, 35 like that, which means after 20 the next contour is at a height of 25 meter. So what is the interval or the vertical distance between two different contours or two consecutive contours? It is nothing but 5 units. Whereas in the second case, that is this figure, it is 10, 15, 20, 25 like that. So there also two consecutive contours are at an elevation difference of 5 units. So there also the contour interval or CI is 5 units. And in the case of third figure, it is 20, then 30, 20, 25, 30, 35, 40 like that. Actually in this figure it is shown as 20, 30 only. 20, 30, 40 like that. But in between 20 and 30 you can see one more line. Similarly in between 30 and 40 you can see another line, which means what? Even though that intermediate line is not marked, it corresponds to the 25, 35, 45 like that. So here also the contour interval is nothing but 5 units. And in the next figure also 50, 40, 30, 20, and in between these marked digits you can see intermediate lines. So that corresponds to 5 units of contour interval. Okay, so contour interval is nothing but it is the constant vertical distance between two consecutive contours. Next is the horizontal equivalent. So contour interval corresponded to the vertical distance between two contours. This horizontal equivalent is the horizontal distance between any two contours. So this can be marked or understood from the plan view only. So if you take this figure, you have contours for 98, 99, 100, etc. So in this figure, according to this figure, the contour interval is 1 meter. Why? Because after the contour for 98, you have 99, then 100. So the contours are at an interval of 1 meter. So contour interval is 1 meter. And if you observe the plan, there is a horizontal distance between each contour. And it is not a constant. See, the distance between 98 and 99 contour is not same as the distance between 99 and 100 contour. So this horizontal equivalent will be varying throughout a single map, whereas this contour interval will be somewhat constant. That is, if you observe, so before 98 it will be 97 and after 100 it will be 101. So contour interval will be somewhat constant, whereas this horizontal equivalent will not be constant. So these are the basic terms that are related to this contours and the contouring. So in the upcoming lectures we can see what are the characteristics of these contours and how we can plot these contours. Thank you.